The Ozone Mapper Profiler Suite, or the OMPS instrument. This instrument will fly on NASA's NPP satellite, and it is a key component to measuring the health of the stratospheric ozone layer.
In the stratosphere, ozone is very important to block ultraviolet radiation from the sun, protecting humans on Earth.
Ozone depletion is mainly caused by chlorine from human-produced substances called chlorofluorocarbons, or CFCs. Back in the 70s, scientists predicted that if CFCs continued to increase, they would eventually destroy the Earth's ozone layer.
So the Montreal Protocol controls the production and emissions of these ozone-destroying gases. And because of that, most of these gases are no longer produced, and they're slowly beginning to decline in our atmosphere.
A critical factor in measuring the success of these regulations, as well as to be able to predict future fluctuations in ozone levels, is the ability to collect long-term data from space. Built with precision and tested by a highly skilled team, the OMPS instrument comes along on NPP as the next generation ozone instrument.
The Ozone Mapper Profiler Suite is an instrument that continues a series that began back in the 1970s. We now have about 40 years of measurements of total ozone around the globe. So this is a key instrument to maintaining that record to follow how ozone is changing in our environment.
OMPS looks at the edge of the atmosphere and builds a profile of data that helps scientists see the vertical distribution of ozone and where it is in danger of depletion.
So that's a big improvement over the old mapping instruments that just mapped out the total amount of ozone between space and the surface.
So the data you get back can produce maps to show you how much ozone is there and how it varies by altitude. It's very important for understanding how ozone is distributed and how it's changing over time.
As NPP orbits the Earth over the poles once every 100 minutes, 14 times a day, the OMPS instrument delivers its data as millions of ones and zeros to a ground station located near the North Pole in Svalbard, Norway.
The ground station then delivers this data in a manner that then is delivered to scientists, and then they take that data and can map the UV globally.
So total ozone data can be immediately used to compute, for example, a UV index. In long term, though, we're going to be looking at the data to determine, is the Earth's ozone layer rebounding from the low points that we saw in the 1990s? That's the long-term science result that we'd like to see.